Hello everyone, this is Joey from Adelaide. Today we will be doing React in HTML5 games. We will be building Flappy Birds with React. So a bit of a motivation why we want to build a Flappy Bird. First of all, we know that HTML5 game is always CPU intensive, and this is a trial to see how React would perform under stress, and especially trying to render 60 frames per second. We will also be using mobx as a state management over here for React. So we'll see how the both of them are playing hand in hand. The other thing is I always wanted to create a game, and in most of the tutorial that you find online, it is always about creating a MVC. I thought I would start a new lesson over here where you create a game, and then you learn React along the way as you learn how to code in a game. So the objective of the this lesson over here is that we only will be using HTML5 DOM, primarily because React is very good in doing the diffing of the DOM. We will not be using any canvas, although canvas is more preferred for HTML5 gaming. So the canvas that I meant over here is actually HTML5 canvas. Um, but however, in the near future, maybe we will do a lesson on how we can do canvas rendering. And the obvious part is we need to create a 60 frame per second, whether the the Flappy Bird is flapping, or is it jumping, or is it falling on the ground and the pipes appearing and all that. uh, we would like to achieve 60 frames per second, so that it will be seen as a smooth rendering, just like any video game. um, the other thing that we will do is we'll use the npm and create react app over here, which is part of the npm package over here to create our Flappy Bird from scratch. So in most of the tutorial out there, you would actually need some kind of a boilerplate GitHub repository to start off with. But in this case, create react app will give us the basic boilerplate to start with, so we are pretty much starting from zero. Isn't that nice? We will not build the scoreboard because I think by the end of the lesson over here, everything you will pretty much know how to create the Flappy Bird game, and obviously you would know how to code the scoreboard yourself. So I will not go deep dive into that, but the main concept is to help you grasp the how React and mobx, and as a game overall, how they all interact together. Will So I've said that already. So mobx as the model, and then the React as the view renderer. So bear in mind that mobx is not just a plain model. It actually do a lot of things. In particularly when there's a state change, it will tell React to go and render the new view. We will not be using any decorators. So if you are curious how to code mobx without the decorator, uh, because we are using a create react app. um, so this lesson we will adjust all the code accordingly to feed it for create react app. Before we begin our game coding over here, a big credit to Max over here. So I've followed some of his YouTube tutorial, and I got a lot of inspiration from his YouTube tutorial. So do go and check his stream out. And if you are interested to build other games like the Asteroid or the Space Invaders, yeah, you go crazy with it. So just a bit of introduction about Create React App by Facebook over here. So if you go and look into most of the React app that is sitting in GitHub repository at the moment, most of them has their own webpack definition and hot module reloading and etc. The way Create React app is doing is that is trying to unify the way we are deploying a React app. So we should be concentrating on creating interesting app rather than trying to fumble how we are launching our setup over here. So Create React app give you all the ease already by taking that away from you, and all you have to do is create awesome app. So you don't have to define any webpack rules or Babel rules. So that is already pretty much taken care in the Create React app, which we will see shortly. So a big credit to the Facebook contribution, and obviously the big community who have create such an awesome development tool, so that you don't have to grind down and trying to figure out how webpack should work. So webpack at the moment, or the Babel or the ES linter and all that, should be transparent to you, and you should not be worried about that anymore in the near future. So a bit about React for those people who have not heard of React before. React is powerful um, in declarative programming, but what it means by that is that you would only declare or you would actually say that what is your final presentation, and React will compare your virtual DOM with your current DOM, and knows the specific change for your DOM, and then make only those changes. So with that in mind, you don't have to go down into detail how things should be done. So all you have to tell React is, this is my final outlook, and I want to render into that right now. So React can do this quite efficiently because they use the DOM diffing algorithm, and so in that aspect it is considered somewhat declarative. And but I just want you guys to know that it's not totally all declarative. There's still some imperative programming that you have to still do to make your React application work. So where are we going with this anyway? So this is a snippet of the blueprint taken from Unreal Engine. So I would say this is the future that we should be targeting, where everything is composable as a smaller unit of component. Um, so one thing that we can unit test a smaller component, and then it is more uh, easy to understand um, what is the architecture and the intention of the whole code over here. So if you are impatient and you don't want to wait for the future to come on the JavaScript platform, um, you can go on and use C++ and Blueprint to code in Unreal Engine. So a bit of the structure of the source code. Um, so we have the common folder over here, where under the common folder we have common.js and the sprite.js. And in the common.js we will be storing our window size or browser size in this particular source file. And then the sprite.js is where we have our static crop sprite, mainly because we have the a big sprite sheet where the when the user requests on the server, you essentially you want it to download just one big file which consists of all your sprite, and then your sprite.js will be the one handling all the cropping and create static div element which will be rendered on your canvas in a later part. And then after that we have the store, where the mobx will watch all the state change. So our initial state will be declared over here, and our game logic, you know, which is our collision collide, and um, and our handling of the pipes appearing on the north or the south, and the bird, whether it's what is the velocity of the jumping. They all will be coded in this part of the source code. And then the game logic will update the state when it is required. And then on the app.js, mobx will sort of do some sort of not state passing, but it's actually observing all the state changes on the store, and it will tell React to render the DOM when there is a change required. And for the obvious reason, the game looping will happen here. So all the recording here is has been already pre-recorded. I have already done all the refactoring, mainly because I came into some bottleneck on the CPU much earlier, so I don't want you to waste your time trying to do the same thing. So I'll just show you directly how the end result will be. But the big takeaway here is the separation of the logic from the view. So as you can see here, we have a very distinct category of where things should be. So all the state management is under the store folder, whereas the app.js is only handling all the view. So it doesn't know anything about the game logic, whether what position the bird supposed to be, until mobx tells it that you need to render in this position. All it knows is what it should render, but it doesn't know what are the game logic should be, or what state it should be. So this really gives us a big win in front end programming. So let's not waste any more time and start coding. So we'll start off with create React app and give a folder name, Flappy Bird in this case. And create React app will create the new folder and install all the necessary package. CD into Flappy Bird, and then start the editor. So this will give us the boilerplate structure. And then if we npm start, we'll see the React basic app, which is started on port 3000. So the first thing we want to do is we will import the spreadsheet, and then next we need to import the mobx and mobx React package manager package, sorry. So next up we will create sprite.js, which will do the cropping effect. So we will create a React stateless function which will return us a dumb React div class. So we have added a few more other information in our div class, so that we can use this information in our main.js and in our store.js, in particularly the width and height of our sprite. So after completing the function in sprite.js, we just want to try it out in our app.js to see if it works. We will render the bird onto our view. So we have proved our sprite function is working. Now it's time to create our first background sprite. Then we will create our canvas. Our canvas is a fake canvas which is using the div as a canvas. We will now create the width and the height using the browser inner HTML width and height. Now we will use the windows or the browser width and height in our canvas. Now we will create store.js and asset.js for our state management. We will use mobx to monitor the sprite position in the canvas. We will extend our background to inherit base object. We will now create two background object and push it to the bottom of the canvas. And then we will create the background as our initial state. Now we will pass the store state into our view element. We will render the background using the map function. We will import the background height and the width into our state or into our store. We will ask mob X to monitor the state changes. We will create a higher order component called the sprite wrapper, which will take in the sprite as the child element. This will allow us to render the sprite position onto the canvas. Now we will create the background component, which will use the sprite wrapper and the background sprite. It's time to build the foreground for Flappy Bird. We will now create the foreground component on the view. We now have a static foreground, but the foreground are meant to be moved. We will use a frame in the store to control the foreground movement. As the frame increment, the foreground will be going back and forth. We will use component did mount to update the frame. What it means is that when the uh, app component is rendered onto the view, then the update of the frame will begin and the frame will increment. We are using a request animation frame instead of set interval to do our game looping. Again, as a reminder, we should use mob action to wrap our store update. We need to pass the update frame action, which is a store update frame action, back into our view app. Once we done that, then our view can invoke the update frame method, which is sitting in the store. So we have our first screen where our foreground is now animating. As you can see from here, when the frame is incremented, the foreground position is also toggling. That's why we have the animation effect. Note that the request animation frame is much more better than the set interval, mainly because it can also work for a low powered device, and also for device which have a lower FPS. Now that we have the animated foreground, we need the Flappy Bird. We need at least 3 bird to create the flap effect for Flappy Bird. And don't forget to export the bird height and the bird width so that it can be used in the store and I think it's only used in the store. You now create a bird higher order component. We need to use the switch operator to select which bird it should render on the view when the bird frame change. The order of the bird is important. Um, the one on the bottom will overlap the component on the top. Great. Now we could see a Flappy Bird in our canvas. Now we need to make Flappy Bird flap, obviously. We will make a Flappy Bird flap at every 10 frame, or change animation at every 10 frame. We will now update the bird when the browser requests for update frame. So now we can see that Flappy Bird is flapping quite happily. So next we need to plan for Flappy Bird's gravity. Just a side note that the bird dot cy, which is the bird height over here, when it is positive, it is going downward. I always tend to get confused sometimes. Also, if Flappy Bird is not flying, it should be dropping, so it should face down. So our Flappy Bird managed to drop to the bottom, but it lacks for the rotation in the view, so we have to manage that in our bird component. So if we refresh our browser, Flappy Bird is going to drop down with face down. So now we need Flappy Bird to jump. We will attach the event handler for the bird jump when there's a mouse click. So if we refresh our browser right now, Flappy Bird should be able to perform the jump. Great, now we can start to code the pipes. We will initialize the pipe with empty array. We need to observe the pipe when the array is updated. For very obvious reason, we still need to create our sprite definition or our static sprite. And again, we need to export our pipe height and the width so that it can be computed in the store. We need to create a new attribute called type for the pipe, mainly because we have two different pipe. Then now we need a way to update our pipe. What we are saying here is that at every 100 frames we will render two new pipes. So once we have the new pipe should move towards the left as the store.frames get updated. Also, as the pipe move out of the canvas, it should also naturally be removed. Otherwise, we end up with a lot. Again, on update frame, we need to update the pipe as well. Now we can create the pipe component in the view. Now that we can see the pipe slowly moving towards Flappy Bird. Now we will start coding for the bird and the pipe collision detection. Here we are trying to calculate the closest point between the bird and each of the pipe. If there's a collision happen, then the game should naturally stop and go into a score state. So as we can see that Flappy Bird stop when it hits the pipe because we haven't programmed the game state as yet. We will do it right now. We should stop updating the pipe whenever the game goes into the score state. For obvious reason, our game has gone into the score state, which you cannot see. But then that's why it's not updating the pipe. So we need to fix that. We'll create a run game action which will change the state into a game state. We need a way to indicate the game is over because the bird has hit the pipe. We will create a OK button so that the user can click it and restart the game. I have hard coded the canvas position of the game over and OK because they do not change over time. So we are almost quite finished right now. We could see when the Flappy Bird hits the pipe, we get the game over and the OK component. So to complete the game, we need the splash screen for the initial start. And also for obvious reason, we should not forget to update our game initial state to splash. So we now have almost running full-fledged Flappy Bird. Congratulations. We also need to indicate that once Flappy Bird touches the ground, the game is over. For obvious reason as well, we need to put in the on-click handler when the user click the OK button and the splash screen button, it should initiate the game state change. So like I said before, the position is quite important. As you can see, the pipe is overlapping Flappy Bird. So let's fix this up. The other cool thing that we want to do is when during the splash screen, we want Flappy Bird to hover up and down in the middle. So now we would like to do some code cleanup so that we don't have all these ES lint error. So great, our ES lint error or warning has gone away. We can now proceed to do the production build, right, by running npm run build. For this task, you may need a push state server, but you can also use other web server. So the other thing I would like to do once I reach production is I would like to profile it. You could also profile it when you are in development mode. In my experience, using npm run builds really give you some performance edge. What I found out from the Flappy performance is it double ups. As you can see from the profiler over here, the result is quite satisfactory because overall we had almost 60 frame per second. So some final thought in creating Flappy Bird using React, I think it's quite fun, and you could see that React is quite performant even under um, stress over here because it need to achieve 60 fps. um, I would say the other thing looking forward is trying to dig deeper into the profiler. I did take a look, but there are many parts that I still didn't quite understand. I might poke around and start asking question into the community. If you have um, any video regarding React, running React and profiling it and having a better understanding, I would hope you could share it with the rest of us here. Um, so that's it. If you like my video, don't forget to like, comment, and subscribe. Thank you.